Welcome to The Explainer. Today, we're going to pull back the curtain on OAuth 2.0. It's kind of like the invisible security guard of the internet, and it's the real reason you can let an app access your photos without just handing over your master password. Okay, so let's just dive right in. And to do that, we have to start with a really fundamental problem, a massive security headache that used to plague the internet. So, picture this. You find a fantastic new app, maybe one that organizes your photos. Now, for it to work, it needs to get into your Google Photos. The old way of doing things, well, the app would just ask you straight up for your Google username and password. Just think about that for a second. You're literally handing over the keys to your entire digital kingdom. That is a huge, huge security risk. Thankfully, we've all seen the solution to this problem everywhere, right? Those super convenient login with Google or sign in with Microsoft buttons, they are the friendly face of a way more elegant, way more secure system. And it's all powered by a framework called OAuth 2.0. So what in the world is this framework? And how does it work like a valet key for your data, letting you give out very specific permissions without just giving away the master key to everything? All right, this is the most crucial point to get. OAuth 2.0 is an authorization framework, not an authentication one. You see, authentication is all about proving who you are, but authorization is about defining what you are allowed to do. And trust me, that little distinction changes everything. The absolute best way to think about this is like a valet key for your car. That key lets the valet do one very specific, limited thing: park your car. They can't pop the trunk, they can't get into the glove compartment, and, most importantly, you can take that key back whenever you feel like it. It's all about granting temporary, limited, and revocable access. So, to really get how this digital valet service works, we need to meet the key players in this whole process. And first up, the most important one, you. You are the resource owner. It's your data, it's your calendar, it's your contacts. You're the boss. Next on our list is the client. Now, don't let the technical term throw you off. This is just the application that wants to do something on your behalf. Like that new social media tool we were talking about. Then you've got the big trusted player in the room, the authorization server. This is the service you already know and have an account with, like Google or Microsoft. Its whole job is to verify that you are who you say you are and, critically, to hand out those valet keys, which in the digital world we call access tokens. And last but not least, we have the resource server. Think of this as the vault where your data actually lives. It could be the API for Google Calendar or the server that's holding all your company's internal files. It's what the access token is designed to unlock, but only for very, very specific things. Okay, so we've met the whole cast of characters. Now let's actually see how they all work together in the most common and most secure process, which is known as the authorization code flow. Now, I know this might look a little complicated, but just think of it as a secure six-step dance. It all starts with you telling the app, hey, connect to my stuff. The app then sends you over to a trusted service, like Google, where you sign in directly. And notice, the app never sees your password. Once you approve the specific permissions, Google sends you back to the app with a temporary one-time use code. Now, here's the really slick part. The app then, behind the scenes, securely exchanges that code for the real access token. It's that secret back-channel exchange that makes this whole thing so secure. So that's the theory. But what does this actually look like in practice for, say, a developer? Let's take a peek at how you'd build this using a real-world system, something like Microsoft's Azure. For any developer who wants to plug this into their project, the process starts in their cloud platform. In Azure, for example, it really just boils down to these three core steps. First, you register your application to let the system know it exists. Then, you generate a secret password for the application itself. And finally, you spell out the exact permissions or scopes that your app is going to ask the user for. Once you finish that registration, Azure gives you three key pieces of information. You get a public client ID, which is kind of like a username for your app. You get a tenant ID, which just identifies the specific company the app belongs to, and you get that all-important client secret, which is basically the app's private password. And where do all those values go? Well, as you can see right here, they get plugged directly into the application's configuration files. These settings are exactly what allow the app to talk to the authorization server and kick off that whole secure dance we just walked through. Okay, let's wrap this up with a couple of key takeaways to really bring it all home. So, the first big takeaway is this. OAuth is not a one-size-fits-all solution. That authorization code flow we talked about, it's perfect for web apps. But if you're building a mobile app, you need a version with an extra security layer called PKCE. And for secure communication between two background services, well, that's a different flow entirely. Picking the right tool for the job is absolutely critical. And let's clear up one final, really common point of confusion. You're going to hear about something called OpenID Connect, or OIDC. Just remember our distinction, right? OAuth 2.0 is about authorization, what an app can do. OIDC is just a thin layer built right on top of it that handles authentication, confirming who you are. They work together beautifully, with OIDC giving you a standard way to get user info after OAuth has already granted the access. You know, at the end of the day, understanding OAuth isn't just for developers. It makes all of us smarter digital citizens. Every single time you click Login with Google, you're actually taking part in this really clever, secure exchange. And it forces all of us to think about a really fundamental question in our connected world. Your digital identity is incredibly valuable. So who do you really trust to hold the keys?